Monoliths to microservices, Kubernetes and containerization in the DevOps journey. This session will be conducted by Mr. Matiur Rahman, Senior Associate Director, DevOps, InsuranceDekho. Let me give a small brief about sir. With over 14 years of DevOps experience across travel, gaming, and insurance domains, Sir has consistently delivered scalable, secure, and cost optimized infrastructure that powers high performance digital platforms. His work blends automation first thinking with deep domain knowledge to streamline development, workflows, and accelerate innovation. By aligning DevOps roadmaps with business outcomes, Sir has helped a lot of teams improve system resilience, reduce deployment friction, and maximize ROI through automation, governance, and intelligent cloud management. With this, ladies and gentlemen, let's welcome our next keynote speaker, Andreas, with a round of applause, some energy into the room. Come on, everyone.
Hi, hello. So my name is Matiur Rahman. Just first, I'm going to introduce myself actually. My name is Matiur Rahman. I have a 14 to 15 year of the experience in DevOps. And you can say the 15 year back, the DevOps word is not existing in the market actually, okay. So everyone just know the Linux admin, system admin, mainframe, like that. So many people is from, actually the agenda of the today is Kubernetes, monolithic to microservices, and what is the pivotal role for the DevOps, Docker and Kubernetes in this transition from monolithic to microservices. So first of all, we need to know what is monolithic. Actually, who is, so the day is too long actually, okay. So you guys is really tired, I think. And so I want to interactive panel actually. So who have less than 5 years of the experience, I don't think so he know about the monolithics, but who have the more than 10 years of the experience, I definitely sure everyone is worked with the monolithic and just migrated to the microservices, right? So monolithic actually, so 10 years back, so the structure is ki a monolithic architecture and microservices architecture, changing landscapes, deployment, scalability, reliability, DevOps tooling, and focus on the automation and observability. So first we know what is monolithic actually. So monolithic, so just landscape the 10 years back actually. So when we are actually just start the DevOps culture actually, DevOps, shifting the DevOps transformation from the DevOps actually. So one of the server is Linux server or Windows server. So Linux server where all of the application is deployed on a single machine. Even sometime databases too. So after 2010, the things is changed actually. So all of the backend service on a same server. So suppose that the code is written in the Java actually. So all the Java, on that time Java 6, Java 5, Java 6 is running on that time. So Java 5, so many libraries. So everything is deployed on a same machine. The scalability. So monolithic means all of the backend services, front end, sometime databases running on a same machine. So and the same code means same repository, Git repository, or on that time the SVN and CVS is running. I mean the Git is not exist on that time or very low popular actually. So SVN on that time. So the same repository, all of the code is actually existing on a same repository. So it's a tightly coupled, and deployment unit is a single, even the fast and single, tightly coupled. All of the developer is running on a same, coding on a same repository and same deployment, same code. Sometimes shared database, sometimes a different database, but mostly different database on that time too. So what is the disadvantage of the monolithic? Why the microservices come in the market? Which type of issue facing by the developers actually? So the main difficulty is ki it is tightly coupled. So suppose that ki one of the code, suppose that we are talking about some travel domain or some insurance domain. Right now I'm working with the insurance domain, so I'm talking about the insurance domain. All of the broker or of the brokerage codes is coming from the same machine. So if one of the developer is write the code for suppose that the four-wheeler or car insurance, and the code is broken on a production somehow. So all of the code is going to be broken, like two-wheeler, life insurance, health insurance, everything is impacted. So it's a tightly coupled, right? And the second, CI/CD pipeline is sometimes difficult. If anything, minute changes, if any image is going to be changed, you need to be redeploy the full application. Means full application is going to be restart, and the frictions is changed. Means some of the user is actually impacted. Most of the user is impacted on that time. Okay, and tightly coupled, fragile नहीं होता था, right? So small changes redeployed the everything. So these type of issues the developer facing on that time, then the developer on that time thinks about this, कि we can decouple the application from the monolithic to small module, through the break into the application into small modules, right? So each services, and right on that time, so the microservice, this is the time of 2011, 12. In 10, the Netflix is also going to be on a microservices in 2010. But the people is thinking about the transformation from the monolithic to microservices. So, and the microservices, what is the microservices? The full code is break into the different piece of the code, like list authentication, user login is a different, scaling, listing of the codes is different, car, health, insurance is a different type of the module. But there are no hard coded rule कि this monolithic service must be deployed into 5 or 10 or 12 microservices. It's totally depend upon your organization culture, line of business. It's totally depend upon your team, actually the size of the team, and your business logic actually. So suppose that I am talking about the insurance sector. So one of the brokerage team is divided into so many modules, so many small modules, like car insurance, two-wheeler insurance, and heavy motor vehicle insurance, as well as life, health, pets, so many insurance. So the different microservices is running. And what is the actually benefit of this? If suppose that we are going to be changing a two-wheeler insurance brokerage microservices, so only the impacted services is a two-wheeler impacted. If some end of the user is going to be book the life insurance, that user is not going to be impacted once you are going to be redeployed. Every developer is independent to redeploy the application at any time. No one is impacted. If suppose that the car insurance is going to be redeployed, or motor vehicle or life insurance, so the other module is not impacted, right? And the most important benefit is कि one of the module is written in a Java, and the developer is come in your company, join the new developer who is proficient in Go, and the code is also required कि this code is going to be scale, boost, and performance is better in a Java Go. So that module is going to be written in a Go module. In monolithic, when the code is written in a Java or PHP, or so all of the code must be written into the Java. Here, once you break in the different module, like small microservices, so every repository is isolated. Every repository, you can write a code in your own language. Like if your company is allowed, you write a code in Go, Node.js, write the TS script, write the Java, so anything. So every developer is independent to write the code in a different languages. So this is the most important things actually. You can redeploy the application anytime. No other module is impacted. You can write the code in different languages. So this is the most important benefit of the microservices. So, but how we can actually move into these services? So on that time, the cloud is also not in a culture just like nowadays. Everyone is on a cloud native. Is someone is Azure, someone on AWS, someone on a GCP. So on that time, most of the things is running on a bare metal. So how we can achieve these things? So on that time, the era of 2014 actually, 14, yeah, the era of 14. Before the 14, the hypervisor and virtual machines we are using. But in a 14, the revolutionary era of the DevOps is a Docker is introduced in the market as a container. So what is the benefit of the Docker? And why Docker is actually come? So which type of problem solved by the Docker or container? Suppose that the code is written in a Java, right? And the developer written the code in the Java in Java 5. One of the developer is coming to my team, and he is using the Mac and install and running the code on own machine. So he must be install the latest version of the Java, right? So the code is written in the Java in 1 year back. So that Java once the Java version is change, so many libraries change in the latest version. So the code is not running on the local machine or any machine. So it is very difficult. So the developer is the container Docker is come in the market, and we build a package of all the dependencies. And the Docker basically use the Linux core system actually, Linux file system using, like C namespace, C group, slices. So C group is actually just using for the memory and CPU control actually, control group, namespace for the isolation, all those things. So Docker is nothing, Docker daemon is actually just using the core feature of the Linux kernel system actually. So we build the image which is a package of all of the dependencies, like you are using node 15, node 18, node 20, whatever the Python module, everything is just installed in your package, push the repository in a Docker Hub or where you are using a repository like ECR or Docker Hub or whatever, and anyone actually just pull that repository and run the machine, run the container in anywhere. Like on right now on a Windows system is also you can run this code. So the Docker is actually container is you can say solve this type of problem of the dependencies, module, coding, these type of the things. But how we can run the Docker on a production server? How we can manage? So at the start of 16, the Kubernetes is actually just introduced in the market, is open source. So on that time, on starting of the 16, the AWS is also not providing you Kubernetes as a service. And we are actually just installing on a bare metal Kubernetes server. Once the etcd is actually just running on a 2. So after 6 months, this is a very challenging task to our team actually, to ourselves. We migrate all of the etcd to etcd3 actually. So the Kubernetes is actually introduced by Kubernetes is nothing. Kubernetes is the orchestration tool of the containerization, where he can actually manage the deployment, manage the container, manage the things actually, self-healing, auto-scaling, and right now the Kubernetes version 1.33 actually just we also provide you a virtual pod scaling is also. Previously the HPA is only existing by default, but right now the Kubernetes 23 is also provide the VPA, vertical pod scaling. So Kubernetes is actually manage all of the things. How many desired number of the container or desired number of pods you need to be run. Always secret management. So these things of the Kubernetes is actually just solve the problem from the monolithics to microservices and the microservices. And the Kubernetes and the Docker actually a huge pivot role to these transactions from the monolithic to microservices. And the service mesh, actually, service mesh is nothing. Service mesh is the communication channel between the pods actually. You can use the Istio, you can use the Linkerd for the traffic management. Also, the Kubernetes is also by default feature of the network policy. You can write your own network policy in a Kubernetes, which pod is going to be communicate with which services. So these type of the things is you can write in your network policies, right? API gateway. So API gateway is important actually. This is important because once you are using the microservices, so in monolithic, so each services is talk to be itself, but in how we can communicate with the services in Kubernetes. So Kubernetes also provide you a self auto discovery things actually. You can talk about the service within the Kubernetes cluster actually, but from outside of the network actually how we can connect. So many internet API gateway like Nginx or Ingress controller. By default, the Ingress controller is also you can use in a Kubernetes to API as a API gateway. AWS API gateways also provide. Conga you can use. So many API gateways. So, but I mean, right now I am using the Ingress controller. So Ingress controller is Ingress controller is nothing. Is backend running on the Nginx server actually. So DevOps shift, what is the benefit of the DevOps shift? CI/CD pipeline for the microservices. You can use the GitHub Action, you can use the Argo CD, you can use the Jenkins. So GitHub Action and Jenkins is most popular, and so many people are actually just using the GitHub Action and Jenkins. And the deployment for canary deployment, blue green rolling update. By default, the Kubernetes is provide you the rolling update, but the canary and blue green is actually just due to the high cost of the infrastructure. Once you are running your code in your AWS, the costing is also important. You need to be manage your cost management is also. So rolling update is also, rolling update is a good feature of the Kubernetes for deploying the things actually. So logging, for logging, so many open source tools like ELK, Greylog, so many things, but also paid tool is also available in the market like Datadog, like New Relic, so many things. Matrix, this is the actually most important thing in a DevOps culture actually. So you cannot monitor the things without the matrices and tracing. So matrices in a Kubernetes, Prometheus are really very important and a good tool. So Prometheus, you can monitor your pods, services, anything in your application. So Prometheus for the matrices and Grafana for just UI of the matrices. Tracing for Jaeger, OpenTelemetry, so many things you can use. So, but the matrix is also actually too many important. Prometheus is really very good tool right now actually, what we are using. Stability, auto scaling, individual service based on, so I have already mentioned the HPA and VPA. So VPA is latest, right now just released in 1.33 actually version. Before the 33, the VPA is not available. Is as a default feature of the Kubernetes, but the HPA through the matrix is a matrix server. You can scale your nodes, you scale your pods on the matrices of CPU and memory. Also, you can create your own matrices. Decoupling the database, it's important. Once each services use the different databases, so it's important. Caching layer for the hotspot, so many you can use the so many caching layer in between like Redis cache, Aerospike, so many things actually. It's all also available in Kubernetes as a stateful set and all those things. Async communication like Kafka, RabbitMQ for the high throughput. Challenges, what are the challenges in microservices? Actually, microservices is complex. So operation complexity, managing the codes, managing the infrastructure, managing the services, auto healing, so many things. So the challenges is also, but once you are facing the challenges, so also use the so many amount of the benefits is also, right? Distributed system debugging, one of the application is going to be broken, and the impact of that application is on a third application. So the debugging is really very tough. Network latency, once the things is running on a monolithic, so latency is very low. But you are running a Kubernetes cluster, so latency is high, little bit high. But if you are using a self auto discovery service, server to server call within a Kubernetes cluster, so you can reduce actually. And also you required a mature DevOps team and tooling. This is the most important thing. The DevOps team must be mature, and tooling. The tooling things means ki, which tool is suitable for your organization. Some we are using Datadog, some we are using New Relic, some we are using your own open source tool like ALK. So it's totally depend upon your cost and all those things, right? So that's it. If you have any question, okay, thank you.
Thank you so much. Sir, please be with us. May I invite Mr. Shobit Agarwal, Director AI ML Data Engineering, MasterCard. Sir, please join in to present a small token of appreciation as Sir is here with us, and thank you for the entire session.